Hi there, this is Jeremy Berger. I am a fifth grade math and science teacher at McDowell Elementary, and today we're going to be talking about reading, writing, and comparing decimals to the thousands. Um, we have just finished up across the district using fractions and dealing with fractions, adding, subtracting, multiplying, and dividing. So I'm going to start using the foundation that we already have with fractions and relate those to decimals. So I'm just going to start with 3/10. So in place value, most students are familiar with the ones, tens, hundreds, thousands. And then in decimals, you have tenths, hundredths, and thousands. And invariably, every year, one of the first questions I get asked is, why are there no ones? So I'm going to take a look at this fraction, which is 4 over 1, and we're going to demonstrate why there is no ones place. If you have 4 over 1, that is a whole number of 4 wholes. And to demonstrate that, I can simply do that by showing you visually here what 4 over 1 looks like. I have 4 wholes, each has one piece. That is 4 over 1, which is 4. If you were going to put this into fractional parts, there are no fractional parts. There are only wholes. So if I were going to, on this place value chart, put 4 over 1 up here, it would be in the ones place. So there are no ones, because if you have a denominator of 1, it is a whole. So that is why there are no ones. So if we go back to the 3/10, we can draw 3/10 visually here. And I would have 3 of these shaded. This is something that most fifth graders can do relatively easily to show what 3/10 is. Because it is a fractional piece, we are going to have less than a whole here. So in terms of a decimal, here would be my ones place. I have less than a whole. And how many pieces do I have? I have 3/10. So if we look at our place value, tenths is our first place value, the way that I would write that as a decimal would be 3/10. The way that I would write 4 over 1 as a decimal would be 4 wholes, 0 fractional pieces. If I go down to my 23/100ths, I could draw a hundreds chart. So I have a 10 by 10, and there are 23 of these shaded in. So one whole row is 10, 20, and then 1, 2, 3. So if I'm looking at my decimals and I'm trying to go from my place value again, how many wholes will I have? I will have 0 wholes. That would be in the ones place here. And then how many tenths would I have? Well, this is a tenth, and I have 2 full tenths, and then 3 pieces of this 100 left over. Now the other way that you can look at that is there are 23 out of 100 shaded. So I do like to talk about how the tenth spot has 2 full tenths in it, though, because that helps them to understand the place value a little bit better. We can also look at equivalent fractions and how those would work. So if I go back to my 3/10 and I wanted to turn that into an equivalent fraction with hundredths, most students, again, could look at this and say, well, if I wanted to turn it into a hundredths, I have to take both the numerator and denominator times the same number. That would be 30 hundredths. So if I wanted to write this in hundredths form, I have 0 wholes and 30 hundredths. So that would be how equivalent fractions work with comparing these. To actually do the comparison, it's very similar to how alphabetical order works. So usually what I start doing is I will write some words down. And I will ask the students to put those into alphabetical order. Most can do that pretty easily. And then I simply take that over to dealing with numbers. So when you're going to put numbers in order, again, you want to look at place value. Now, it helps to know what order you're putting them in, from greatest to least or least to greatest. I would like to put the smallest number first. So as you start with this, most students will start by looking at the first letter. You want to do the same thing with the place value. So in this case, I have 2 of them that are zeros and 1 that is a 1. So I know that this is the largest number I have. That will go last. And then I'm left with looking at these 2 things. Now if we go back up and we look at our equivalent fractions, when you are comparing decimals, just like when you're comparing fractions, it's easiest to do it if they share something in common. For example, in this case, place value. So I have 3/10 and 32 hundredths. To really truly be able to compare, I want to make these have the same place value. So just like I did up here, to turn the 3/10 into 30 hundredths, I transferred that down. So if I'm trying to compare these, it's pretty evident now which is smaller, 30 or 32. So 30 hundredths would be my smallest, and 32 hundredths would be my middle number. So when you're comparing decimals, it's very similar to putting things into alphabetical order. You start with the place value and you work your way through the numbers. And again, if you need to make something that is equivalent, that's the easiest way to do it.